Section 3.1 is on frequency distributions. A frequency distribution is a summary technique that organizes data into classes and provides in tabular form a list of the classes along with the number of observations in each class. So imagine that you had a big set of data, maybe something like 30 numbers in front of you. Maybe it was the heart rates of 30 different patients. Just looking at that big set of data, you'll be able to tell a couple of things, but if you didn't have any names or anything like that, you were just looking at the raw data, there's got to be some way to take that data and organize it in a way that would be helpful for others to understand the data a little bit better. Okay? And making a frequency distribution is a method of organizing that data. So, there's all different types of frequency distributions and the way that the data is given. Let me show you an example real quick of just a basic frequency distribution. This frequency distribution, you don't have to copy it down, it's in your book. This frequency distribution, it says, is frequency distribution state 10-year population growth rate. It's a state 10-year population growth rate. And then this would be the percentage population growth between these two, I guess, in 10 years. And so it's not just one state, it's all states. All right, and then it tells you how many are in this class. These are classes, these things listed here. All of those are classes. And so a frequency distribution table will take the number that's in that class and list it. So, what this means, this number right here, 7. This means that 7 states were between 0.01 to 5, and I would think that's probably, yeah, it is percentages. So, between 5.01% and 5%, there were 7 states. Between 5.01 and 10, there were 18 states. And so this just is a way of summarizing data so that someone else that was looking at the data would be able to understand it. Okay, so you start with just some big raw set of data, and then somebody takes that set of data and organizes it and puts it in a frequency chart. And then we have to be able to interpret that data. And of course, you know, it could be just really any type of data. It doesn't have to be one type or another. You can look and see that the difference between, you can count this first as a class, because below 0, I guess that means there was no growth, right? But you can see the difference in these classes, say from this lower number here to this lower number here, and this lower number here to this lower number here. These are all the same differences. Okay, and the same for the upper number. I'm calling them just real basic terms. They do have like official names, but like from this upper number to this upper number, you can see the difference there is it's pretty uniform as you go down, meaning it's the same as you go down from class to class. You know, and that's the way that you would want the classes to be, because if they weren't, then the data could be very misleading. You could try to trick somebody maybe, or something like that. We don't want that to happen. Alright. So your book does go through several examples of frequency distributions. And some frequency distributions may have percentages. Some may have just counts like this, or just a frequency. So there are several different types of frequency distributions, and 3.1 just basically gives you 4 or 5 examples. I'll show you a different one that would just have percentages, and this is called a relative frequency distribution. So you can see these classes. This tells you, it says, in general, how would you rate the quality of American public schools? So these classes don't actually have numbers, they're just the ratings that were used. And then someone took all of the raw data from this survey and they converted over, instead of telling you how many people thought that it was excellent, pretty good, fair, poor, or not sure, they converted this to a percentage. Okay, so just another way of representing data in a frequency distribution. And that's pretty much all of 3.1. 3.2 is on qualitative data. It's on displaying qualitative data graphically. All right. So think about, why would we want to show people graphs? Graphs can be very misleading. Depending on the way that you set your X and Y axis scales, some data could be presented in ways to maybe sway your opinion on something, believe it or not. That doesn't mean that graphical data isn't important or that you should ignore graphical data, because pie charts, it's kind of hard to make a pie chart show you something misleading. A lot of times it's done with mainly bar graphs or bar charts, things like that, histograms. There are ways to manipulate the y-axis, if you think about the vertical axis, so that things look like they're actually a lot more than they are. So it is important that you look at those scales and understand exactly what you're looking at. Your book says that there is a graphical analysis trade-off, and I'm just reading this out of the book. We lose sight of the individual observations or the raw data whenever we use these graphs. In return, we're able to see a representation of the totality of observations. The trade is almost always beneficial, since a well-designed graph gives our visual processing system the kind of image it processes best, a picture. So as long as it is a well-designed graph, then of course it would be worth looking at, because that's what we do. A lot of times pictures can tell, can say 1,000 words. I'm sure you've heard that saying. But yeah, there are some good things about a graph or graphs, and the one thing that your book points out is the actual way that your mind interprets graphs can help you understand the data a little bit better.